Default object methods are special methods provided by Java for every object. They include toString, hashcode, and equals. These methods can be overridden to provide custom implementations. The default implementations in the object class are based on the memory address of the object. It is recommended to override these methods in a meaningful way for each class. Here is an example of a class that overrides the default object methods. The toString method is overridden to return a string representation of the myClass object. The equals method is overridden to compare the myValue fields of two myClass objects. The hashcode method is overridden to generate a hashcode based on the myValue field. The toString method in Java is used to convert an object to its string representation. It can be overridden in custom classes to provide a custom string representation. The default implementation returns the class name, followed by an @ symbol and the object's hashcode. It is often used for debugging purposes to easily view the object's contents. The toString method can be overridden in custom classes. Here's an example in the person class. It returns a string that includes the person's name and age. The equals method is used to compare two objects and determine if they are equal. By default, it compares the memory addresses of the objects. To provide a custom comparison, we can override the equals method. When doing so, we should consider the following characteristics. When overriding the equals method, it should implement an equivalence relation. It should be reflexive, symmetric, and transitive. It should also return false when comparing to null and when comparing objects of different classes. Furthermore, it should be consistent in its results. Here is an example of overriding the equals method. In this example, we first check if the two objects are the same by comparing their memory addresses. If they are the same, we return true. Next, we check if the object is null or is of a different class. If either of these conditions is met, we return false. Finally, we implement our custom equality comparison logic and return the result. The hashcode method is used to generate a unique hashcode for objects. The default implementation returns the memory address of the object. It is important to override this method in custom classes to provide a meaningful implementation. The hashcode method is typically overridden in custom classes to provide a custom implementation. The implementation should calculate and return the hashcode of the object. The getClass method returns the runtime class of an object. It is a final method and is automatically added to every class during compilation. The method returns an object of type class which can be used to obtain various information about the class at runtime. The getClass method is defined in the object class and is inherited by all Java classes. It can be used to determine the actual type of an object when it is known only as a reference or when the object is of a superclass type. For example, you can use the getClass method to obtain the runtime class of an object and then perform specific operations based on its actual type, as shown in the example. The finalize method is used to perform any necessary cleanup or resource deallocation before an object is garbage collected. It is called by the garbage collector when it determines that there are no more references to the object. The finalize method is defined in the object class and is inherited by all Java classes. It is a protected method, which means it can only be accessed within the same package or by subclasses. By default, the finalize method does nothing, but it can be overridden in a subclass to provide custom cleanup logic. For example, you can override the finalize method in a subclass to release any resources held by the object and call the superclass's finalize method to let it perform its own cleanup logic. The clone method is used to create a copy of an object. It is a protected method defined in the object class and is inherited by all Java classes. To clone an object, the class must implement the clonable interface and override the clone method. The clone method creates a new object that is a copy of the original object. The type of the cloned object is the same as the original object. The copy is shallow, which means that the cloned object contains copies of the original object's fields, but they reference the same objects as the original object. To create a deep copy, where the cloned object has its own copies of the original object's fields, you must implement a deep clone method. For example, you can override the clone method in a subclass and call the superclass's clone method to create a shallow copy of the object. Here is an example of using the getClass method. Public class example, public static void main, string, args, string str equals hello, world, class equals str. getClass system.out. println, class. In this example, The program creates a string object and uses the getClass method to obtain the runtime class of the object. It then prints the class to the console. Here is an example of overriding the finalize method. Public class example, protected void finalize, throws throwable, perform cleanup logic here super. Finalize, in this example, the program defines a subclass that overrides the finalize method to provide custom cleanup logic. The subclass calls the superclass's finalize method to let it perform its own cleanup logic. Here is an example of implementing the clone method. Public class example implements clonable, add override protected object clone. Throws clone not supported exception, return super. Clone, in this example, the program defines a class that implements the clonable interface and overrides the clone method to create a shallow copy of the object. The clone method calls the superclass's clone method to obtain the cloned object.